This podcast is brought to you by LMU Munich.
Welcome, everybody. Please come in and have a seat. I'm very excited to announce our next speaker, Rafael, who will be talking about Python testing.
Hi. Can you hear me? Can you hear me? Yeah? Like, is it working?
Yeah, it works. I can turn it up a bit.
Okay. Today I came here to talk about reliable and effective tools for testing professional Python code. Not only testing, but developing as well in general. Sorry. Okay. I'm backend engineer at Zalando. I work in continuous delivery team. My name is Rafael Caricio. I'm developer for about 10 years, like 7 years I'm working with Python. I'm an open source enthusiast. I have made some contributions in various projects, Pipe and Splinter, Tambor. I'm currently focusing on maintaining connection framework. It's an API specification first framework on top of Flask. I'm from Brazil. I lived in Poland for 3 years. I have my fiance Polish. That's why I have this strong relationship with Poland. And I live in Berlin currently. Okay, so let's move on. The path to sanity, what I mean by that is like many people still have problems with installing Python in their machines, or they don't know which version of Python is running, or from where this version of Python is running, or they use the system Python and then they break it, and we have things like that. We recently had this happening in Zalando. Someone just uninstalled forced to remove -rf Python 2 from their machine, and they didn't know. Like, oh, I just want to reinstall Python, and yeah, it's not working. I don't know what's going on, and yeah, you have to basically reinstall the system. Another thing, like I also got involved in developing open source testing frameworks, so I had some experience like trying to, from scratch, build some testing framework. Like we tried to port this JS, Vols, BDD framework for testing in JavaScript, Node.js to Python using asynchronous execution some years ago with some friends. But then we realized like we should not just reinvent the wheel and implement from scratch. There's so many nice tools around. And then there is this problem of setting up CI systems that you just copy and paste this shell script that someone is using a different project. So today I would like to show you how I pass over those problems and how I have like some clean tests, and maybe you get something interesting for you and you can try out. So what we want in the end is like clean test cases written under an isolated development environment and executed across multiple Python versions and uniformly. So I want the same thing executed the same way in different Python versions. So how I have this now, I will show you and how it works, which tools. For clean tests, like I rely on Pytest. Pytest are a very easy way to write tests. Very simple, not much boilerplate, clean error messages, done like just using assert and stuff. There is a simple API, so you remember like how to set fixtures and stuff. It's very easy, very good documentation. There are many plugins for different things, report coverages, and distributed tests, so distributed machines you want to run tests, so like parts of the test, or different processes, multi-process. And it runs Django test cases, node tests, unit tests. Like I tried all those before, and in the end, I realized that Pytest was the best tool for my use cases. So basically, you just write like a function, like in nodes, like just Python function that starts with tests, and then use assert. There's no like wrappers over assert, and that's it. you just run Pytest, the module where your tests are stored, and then it will run your test. Cool thing, when there's an error, there's a wrapper around the assertion function, so it's nicer than the default one. So you can see like, oh, okay, this was the value that was expected, and this is what I passed there. So it's really cool and improves your productivity. You just see exactly what is wrong, and then you can fix it and make it and go on in your development. It also shows like what versions are installed and what's running. It's really cool. There are clean interface for tests. Like you can see the Pytest, mark, parameterize. Like there are many other tools like this. Just use those values for running the same test function. So you have kind of template test. And then for fixtures, you basically just Pytest fixture. This function will be the name of a parameter that you can create tests that receive this fixture. And then there is other options that you can set. So this fixture can be reused and stuff. So, but I just want to see that it's very concise. It's very simple. There is no like crazy names, and this Pythonic, like it's not like unit tests that you have camel case and stuff. You just you have your code, like flakeates passing, everything is fine. Good documentation. You can see the documentation is very vast. So everything I needed, I always found the documentation. So if you need anything, if you have doubts how to create parameterized tests, everything you should find in the documentation. There are some extensions to Pytest. So those are the ones I most used. There's the XDIS for distributed testing, Pytest coverage, Pytest conf. Pytest Django is basically just setting up the Django settings globally, so then you can test your Django application. Pytest BDD, so you can create this textual descriptions, and then Python test functions that execute over this textual definition. And Pytest Splinter, which basically, Splinter is a project that runs your browser. Like you can pragmatically execute actions in the browser. So you have these helpers in Pytest that you can easily set up to run tests in Pytest and use Splinter. Another really interesting tool is virtual wrapper. I really use this like every day whenever I start a new project, whenever I want to create a virtual env for this specific project. I don't want to reuse anything or mess up any other environments that I have. You can use, of course, Python -m venv here, and it also works. This is exactly what's happening in the background. But this virtual env wrapper basically wrappers these commands that you have to remember, and basically you just focus in two commands, make virtual env, work on this virtual env name, and then you can pip install -r requirements, and you don't need to worry that it's changing anything else. The basic installation for this, you just set up some environment variables, like where you want to save your virtual envs. Everything stay there in this folder, so you don't have virtual envs like spread around your machine. Everything is there in a managed location. And then you sourced this shell script that basically will create those commands, put in your path, and then it will be available. Whenever you have the name of the virtual env in parentheses, you are inside this virtual env, you can just install your dependencies. This is like for development. Really cool. Another really useful tool that I use a lot is this pyenv, basically to install Python versions. There are, I think, all versions of Python, or CPython, PyPy, Gentlon, and everything. So you just do pyenv install this version of Python, it will install everything for you. It will not install globally in your machine. That's the point of this. But yeah, you have easy access to that. You can switch very easily between different Python versions globally or locally in a specific directory. And there's like a very easy command for doing that. It's easy to set up, and it's just for installing Python and changing versions, whatever. Like, there's nothing more. It's just do that. So you can, if you use Mac, you can just do brew install pyenv. If you don't use brew, you just have to clone the repo. I didn't put it here, but you clone the repo wherever you want, and then you put this evaluation of pyenv init in your bash profile. Set 2 environment variables, which is the pyenv root, so where's your pyenv, and put the pyenv binary directory and shims directory, which is not here, but you have to put the shims directory in your bash profile, so all the commands from pyenv will be available for you in your bash. And there is this concept of shims. That's the only thing that might be not very clear in the beginning when you start using pyenv, because you have available the Python command, and this Python command is not the operating system Python. It will be the pyenv command, but I'll talk about this a bit later. I just want to show you that those are the 3 commands that you have to worry about in pyenv. Basically, you list the versions, you have global, pyenv global, sets global Python, so everywhere in your shell it will be this version of Python. And there is local, it creates like this .python version file in this specific directory, and every time you call Python in this directory, it will execute this Python version that is in this file. So it's like a local Python version. So this shims concept is basically that pyenv creates binaries or wrappers or links to every binary that have in different Python versions. So if you have pyenv in your home directory, like .pyenv, there is this shims directory that have all the commands, like a wrapper, like a link to all binaries across all Python versions. So whenever you have, like, let's say, AWS CLI installed in Python 3.5.2, and then you are using Python 2.7 globally, and then you type like AWS, it says, okay, this command doesn't exist in this Python, but it exists in this version of Python. So it's really easy to know, like, okay, I just have to switch the version, and if you know this concept of shims, that is just links to binaries in Python, in the Python versions, you basically know that this command is not available here, you can just link again, but you know that you install at some point this. Whenever you install anything that creates binary, like creates execution command, create commands in Python, flake8 for example, you should just run pyenv rehash, and it will generate these links for you in the global pyenv environment. If you use virtual envs, you don't need to do that, because whenever you are inside the virtual env, those commands will be available inside, because it will update your path whenever you are in the virtual env. So it's more like a global installation. Another very interesting tool that I use a lot is this is Tox. Tox is basically a standardized way to run your test suite. You just define once, and then you can run in many different Python versions. You can also verify if your Python project or Python package is installing properly, because this needs to install your version in this virtual env to run the test. So this is also good, because sometimes you make some modifications in your setup py, and then if you run Tox, you know that it will install and it will test the installation, basically. And it's a single command to run your integration in your CI, so you just don't need to write these shell scripts anymore. You just run Tox, and it will run everything as you define in the Tox init file, which this is the minimum you can have. You just say, I want to run this in Python version 3.5, and the way you run tests is just Pytest test, and that's it, and you have to write your setup py so it knows how to install this in this virtual env. How it works is that when you run the tox command, it will create a virtual env for this Python version that you defined, and then you install your package, and then you run the test over this package that is installed. So, and it shows everything, like which version of Python it runs, the dependencies and everything. So if you have some problems, sometimes I had problems that I was running the test with different version of dependency, and like this output really helped me to know, okay, this what's wrong. Like I'm using a different version here. Version resolution is wrong. There is one thing that I want to point out about this, is that sometimes it reused the environment variable for this version of Python that you are creating. So if you want to use it, sometimes the dependencies are not updated because it don't install, because it's already installed the previous version. So you just have to run tox -r, and it will recreate everything from scratch. So this is one common problem. And then you can go crazy and like have completely different virtual environment setups. So you can have like, I want PyPy with the minimal versions of my dependencies, the PyPy version of this package, the latest release, and the development version of this dependency. So then I have this matrix of tests, and it runs all of this, and also I sort to check if like the developers are using the same format, following the code style, and flake-it. So basically, we have clean test cases using Pytest, written in isolated development environment using virtual env wrapper. We execute across multiple Python versions, easily installed using pyenv and managed. And we run those tests uniformly using tox. So every time you run your test, you run the same way. Those are the references for this. If you want to dive deeper into those tools, there is a really cool course in Python Academy by the developers of tox and developers of Pytest and tox. So yeah, it sounds very interesting. I put this presentation available for you later, and this is how you can find me. I work at Zalando, so we are hiring new developers. So like ours, there's about 30 people join the company every month. So you can come and work with me in the delivery team or in some product team if you have a product mindset. And that's what I wanted to present to you today. I hope you enjoy.
So, who has some testing questions? Hands?
Okay. Here was one.
Any experience running parallel tests, let's say, where it requires complicated
Do you mean different hosts or in local machine?
local machine, for example, when you have, for instance, Django application and you want to run it like split the test into 4 separate processes.
Yeah, I try to do that with I developed this connection framework, and I tried to set up this to run in parallel in different processes. And in the end, it was slower than running it sequentially, because I was just reusing if I run sequentially, I can just reuse the bootstrap of the environment, and this was taking like a few milliseconds, and if I was running this in parallel, it was taking these times the amount of this, and it was just waiting, so it was slower than running sequentially. So that's the experience I had with this specific case, but I believe if you could share this bootstrap, it would be cool. It would be a problem to set up different servers because you had to manage the ports and then this test had to run. But there is a way to do that. You can do this kind of thing. You can set up, you can create bootstrap tests for every different host or process in Pytest using Xdist.
Are there some other questions?
How are the test results presented? I mean, imagine you running several hundred or thousand tests. Nice overview. Is there also something available that presents the test results?
Yeah, if you run your test with talks, like in the end of the execution, it will show all the results of the test. Like that's what you mean? I think it depends where's your CI system, not really on the tool that you use to run a test, because talks it will show you the results. In the end, it will just present in the console. And depending where is your CI, if it's Jenkins or if it's Travis, it will show in the output the results. And yeah, it's more related to the CI environment that you have, I would say. Mm-hmm. Oh yeah, we use Jenkins in Zalando, yes. Yeah, there are some teams that use GoCD, but they are migrating to Jenkins because we have a managed version of Jenkins, which means like we have some plugins like that we developed in-house for like saving money in AWS for like, you don't have the slave running 24 hours or during the weekends, you just have the slaves of Jenkins running whenever you actually need it. So this was developed by like not my team specifically because I'm from the deployment team under the CI scope, and this was by Automata team that developed these tools over Jenkins. Yeah, plugins, personalized plugins. No problem.
Okay, so just as a follow-up to that, my suggestion would be to use a coverage tool. In particular, there are some Python tools to generate an HTML report with all your code, and it highlights the lines that were executed and the lines that were not. And in particular, I like that for branching, so that you know if you have an if-else, you know if a branch was followed in your test and another not. And my question would be your opinion about mocking, because sometimes I tend to use that a lot, and I worry that it might not be a good practice. So I would like to know your thoughts on that.
What I use for mocking?
Yeah, whether you like it, whether you think it's a good thing, because sometimes I see blog posts about people not liking it, people like it very much, and so on.
Okay, I basically use the mock library, the one that just got in the Python, official Python, but I tried different ones, but in the end I realized that the mock, it was the simplest version of mocking you could have, so I just migrate everything to mock. Yeah, I don't remember the names of the other ones I tried before, but it was just like I found some corner case that it wasn't covered, and the mocking that got in Python is very heavily used by everyone, so it's very well tested, like I would say. So in the end, I just migrate everything there. One cool mocking library for like requests, there's this responses library that works seamlessly with request library. And you basically mock requests like to external services if you need that in your test. And that's another one that I use for mocking, but not mocking code, but mocking external calls.
Okay, thanks.
No problem.
Thank you. So, small change of plans. We're going to stick to what's in the printed schedule and not the online schedule. So the talk from Arush on optimizing deep convolutional neural networks will be in room Delta, which is just below us. And the talk from Lassa on growing open source community will be in room Omega, as is in the printed schedule. And a round of applause for our great speaker. Thank you.
Thank you.